the thumbs up or just reply in the chat box. So, okay, Bhargava, Lakshmi, Prashant, Payal Chauhan, and Jamie Bhavnagar. Have you all got this? Have any kind of doubt you have? Just write it in the chat box so that I'll get you do not have any kind of doubt in this. Okay? And you are listening to me. The very important thing also. Yeah, Lakshmi, thank you so much. Thank you so much for the attending the session. Thank you so much you all for attending the session. Okay, I hope you are clear with this, what I have taught you. Just keep practicing more and more question and variety of question. Okay. Only Lakshmi is responding, na? No one else. Okay, got it. You are not interested in responding. No problem. Okay. So I've just now stopped sharing my screen and also, okay. Okay then. Thank you so much, guys.
Okay, we will start now. Hello and good morning. I hope you all are good and doing well. And also, you all must have taken your breakfast and ready for the class. You all must have all already attended one more class, right? If I'm not wrong. Okay, how is everybody? JNB, Dahod, Sangli, Vishakhapatnam, Bhavnagar, Arvali. Okay. I hope you all are good. Chalo, theek hai. So in previous class, we were discussing questions from what? Questions from reflection, and we included questions both for reflection at plane surface and at curved surface also done. So in this class, largely we will be discussing questions from refraction done. But in yesterday's class, there was a question and we got answer something that was not correct. This one, right? So if you remember question was what? Image position was changing from 25 by 3 to 50 by 7 in 30 seconds. देखो तुम लोग क्लास में भी ना रिस्पॉन्ड नहीं करते हो. That was a very silly mathematical mistake, I guess. I must say. So if you see here carefully, मैंने सब कुछ निकाला था. I explained things. अगर मुझे फिर से explain करना हो, I will say there was the image and that was moving from 25 by 3 to 50 by 7 in 30 seconds. So initial image position is this. Final image position was this. है ना? Initial image position was 25 by 3 and for this I calculated object position initial done, and also initial uh, final image position is how much 50 by 7. For that we got object position. क्या आया था? एक आया था -50, एक आया था -25. Done. हमें कैलकुलेट क्या करना था, ऑब्जेक्ट वेलोसिटी। तो ऑब्जेक्ट की वेलोसिटी क्या होगी, इट इज मूविंग फ्रॉम 25 टू 50, सॉरी 50 टू 25 इन 30 सेकेंड। सो डिस्प्लेसमेंट कितना होगा, डिस्प्लेसमेंट होगा 25, लेकिन यहाँ मैंने डिस्प्लेसमेंट 2 लिखा था, इफ यू रिमेम्बर। सो आई डिवाइडेड 50 by 25, but we have to calculate displacement, right? So we need to take the difference. Instead of taking the difference, I divided them, and that was the mistake. Okay, in back of my mind it was like yeah, I'm subtracting, but actually I divided, and that is why we got the answer as something wrong. Okay, तो यहाँ पे आप देखो, अब आपको आंसर मिल जाएगा 25/30 मीटर पर सेकेंड. वी हैव टू कन्वर्ट दिस टू किलोमीटर पर आवर. सो this is meter by per second. 1 second will have how many hours? 1 by 3600. So that will go up. And 1 meter will have how many kilometers? That is 1 by 1000. So that will go down. So this is something like this. 20 will get cancelled. And this is 36. This is 36. ये 5 times जाएगा. And then this is 6. And this is 30 by 10. So 30 by 10 will be 3. So 3 kilometer per hour. That was the answer, correct? Okay. So image object velocity relation. Now in yesterday's class, I talked about what sort of things I talked about mirror equation, right? So we solved questions involving mirror equation. Also, what uh, we solved more question involving deviations, you know. And deviation was like if light is falling on certain reflecting surface, then how much deviation light will suffer, and its formula was how much, pi minus I, 2I, sorry. This was the formula, right? And we calculated deviation when light is getting reflected by two mirrors at the same time, right? uh, then so we solved all such sort of question. Also, we were dealing with image object velocity thing. Done. In previous question, or image position was given, image initial position was given, image final position was given, and how much time that position is changing, that was also given. So from that we calculated image velocity, and then we calculated object velocity by using again mirror equation. But how we can write the formula, जैसे देखो, if I say mirror equation is 1 by v plus 1 by u equal to 1 by f. मैं ये क्यों बता रही हूँ, that you will get to understand very soon. Suppose this is your mirror, ठीक है, and there is an object here. So at t equal to 0 time, suppose at t equal to 0 time, object is at a distance u. Done. So for this time, image position will be at certain place, right? Now, if we have to calculate, suppose Karlo, this object is moving like this. This object is moving towards mirror, suppose with velocity v. And we are asked what will be the velocity of image. Nothing else is given. Only thing given is object velocity is this. Let me know what will be the image velocity. Okay? Let me first derive it a bit. After that, I will tell you what sort of question can come. Okay. So first, let's see 1 by v plus 1 by u. One thing you have already studied, if displacement is given as a function of time, suppose कर लो x equal to 2t square प्लस, या फिर ऐसे भी देख लो, तुम लोग मैकेनिक्स पढ़ चुके हो. सो इफ डिस्प्लेसमेंट इज गिवन समथिंग लाइक y इक्वल टू 2x स्क्वायर प्लस x, this is displacement of a ball, suppose, and we are asked what will be the velocity of ball. So what we will do, we will differentiate its displacement with respect to time. So we are going to differentiate it with respect to time. Similarly here, this is v, this is a displacement of image, this is u, displacement of object, and this is focal length, a constant, right? So if we have to calculate velocity of object image from this relation, we can easily do, because this is the displacement relation from for object and image, okay, for certain position, right? So we can calculate velocity by differentiating it with respect to time. So this is v minus 1 plus u minus 1 equal to x minus. Okay. Now what you will do? Just a minute. Now what you will do, dv minus 1 by dt plus du minus 1 by dt equal to क्या लिखोगे, df minus 1 by dt. So this is this. Now this is a constant, its differentiation will be 0. dv minus by dt, इसको क्या लिखने वाले हो आप, इसको लिखोगे dv minus 1 dv into dv by dt, ऐसा लिख सकते हैं, प्लस du minus 1 du into du by dt. Equation is still same, right? Clear है? So differentiation of this thing will be how much? Minus 1 by v square, right? So let's write minus 1 by v square into this is dv by dt. So v is image position, so this will be image velocity, minus 1 by u square, and this is object position u, so du by dt will be velocity of object, and this is equal to 0. Now what relation we are going to get? We are going to get a relation like velocity of image is equal to minus v square by u square velocity of object. ठीक है, this is the relation we are getting. Now let's look at it more carefully. So here v was what? Image distance from where? From pole. ठीक है, from mirror. So v and u was displacement of object and image measured from mirror. So these velocities that we are getting is with respect to mirror. So this is velocity of image with respect to mirror, and this is also velocity of object with respect to sorry, this is also velocity of object with respect to mirror. Now, when we will use this formula and when we can't. जैसे in the previous question, we can't because there जैसे पहले ये कब यूज कर सकते हैं, let's see that. Suppose कर लो, it is given that the velocity of object is suppose 2 meter per second. ठीक है, velocity of object is 2 meter per second and it is given at any time t. Suppose कर लो, object position is at any time t, object position is u equal to 2 centimeter, suppose. Then, and focal length is given, suppose focal length is 10 centimeter. And we have to say what will be the velocity of image at that time when object is at a distance of 2 centimeter. So, for that case, we can simply apply this formula. Velocity of image will be equal to v square by u square, velocity of object with respect to mirror. So according to this question, this is given already, that is equal to 2 meter per second, and u square is given, that is 2 centimeter. V we can calculate from mirror equation and then we can put and we can get the answer. So this relation I just gave you in case you require. Okay. So in ray optics, wherever you have relation of distance position, relation of their displacement vector, you can calculate from that what? Velocity. Yes, for lens also, we will have lens formula for object and image position, right? From that equation also, we can derive their velocity by differentiating it with respect to time. So nothing different we have to do. Simple mechanics we have to apply. Now do this question and let me know what answer you're getting. ठीक है? Read the question carefully. I'm giving you 2 minutes. From the previous equation, we can calculate instantaneous velocity, right? And here we have to calculate average velocity. So whatever logic we have used before that formula, that we can apply here. Because for two time interval is given now, t equal to 0 and t equal to 0.25. So just try to see at t equal to 0 what will be the image position, and at t equal to 0.25 what will be the image position. Then if two time instants are given, we can easily calculate image position at this two time instant if object position at this two time instant is given out. Okay, so let's find it out. This came in CU 80. Question is very easy, you can easily do it. What answers you're getting? Average velocity you have to calculate. Average velocity is what? Change in displacement by change in time. For whatever duration, for whatever time interval, it is asking you average velocity. For that time interval, try to calculate the displacement. Okay, that will give you average velocity, right? So just try to see what is the image position at t equal to 0 and what is the image position at t equal to 0.25. Final image position minus initial image position. That will give you this divided by time. Time is how much? Time difference is how much? 0.25 minus 0. So just you need to calculate this one. Give me answer, everybody. जैसे at t equal to 0, what is the object position? At t equal to 0, distance of object from the mirror is 50 centimeters. Okay, this is this. Now at t equal to 0.25, what will be object position? Object is going to be where? So velocity of object is given, that is 1 meter per second. So initially object is at 50 centimeters. Suppose here it is, and it will move in this direction with velocity 1 meter per second. And what time, in what time we have to calculate it? Yes, Jane B, Vishakhapatnam, it's correct. So at t equal to 0.25, in this time, how much distance object will cover? 0.25 meter. And that is equal to how much? 0.25 meter means how many centimeter? 25 centimeter, right? So by 25 centimeter, it has moved. So what will be its distance from the pole? Initially 50, 25, it has moved towards the mirror. So definitely it is 25. Yani ki finally object is at focus. And if object is at focus, image position for this position will be infinity. And for this position will be some finite value that we can calculate by using mirror formula. But we don't need to calculate. Why? क्योंकि displacement अगर आप निकालोगे infinity minus something करोगे, something x y z. So infinity, say if you are subtracting something, that will give you infinity itself, right? So the answer will be what? Infinity by certain time, a very small time. And answer will be what? Infinity itself. So average velocity of image will be what? V. I hope it is clear. अब देखो, now we are going to discuss questions from refraction through plane surfaces. हमारे syllabus में क्या क्या पढ़ना है? We have to study two types of refractions. Two types meaning when we when we talk about the different curvature through which refraction is happening, then two types. जैसे देख लो, एक curved surface के through refraction होगा और एक plane surface. जैसे light is falling here, ठीक है? This is not a reflecting surface. This is the boundary separating two media, mu1 and mu2. What will happen? Light will refract. It will come somewhere here. ठीक है? It will go towards the normal. If mu2 is greater than mu1, it will go away from the normal. If mu1 is greater than mu2. So this sort of thing will happen. And here also, if light is falling, what will happen? Here normal will change for different points. Normal will change, right? Then, and but if this structure, if this curved surface has a same radius of curvature, suppose this is the part of a sphere like this. This is a part of a sphere of radius r. So for this case, what will happen? What will happen? For this case, what will happen? This surface will have a constant curvature radius and its center will be somewhere. Suppose कर लो, इसका center मैं कहीं यहाँ ले रही हूँ, तो normal will be always directed towards this center. So refraction can also happen through curved surfaces. And for this case, for both the cases, we have to read relation between object distance and image distance. That we will discuss later. But usse pehle, I will define Snell's law. That is true for any kind of surfaces you are taking. No matter its curvature is same throughout, it's a plane surface, or its curvature is changing very much. So at any point, if light is falling, okay, at that point draw a normal. Okay, so I have drawn it. This is angle of incidence. This is angle of refraction. So Snell's law मैं derive नहीं करने जा रही. I'm just going to give you the formula. So Snell's law says that he says that mu1 sin I, ठीक है, light is incident in media mu1. So mu1 sin I will be equal to light is getting refracted into media mu2. So here I will write mu2 sin R. So for solving question, what is important is how we write things, how we write laws. How it is getting derived is also important sometimes, but not always. Okay? And in this case, it's not that important. Mu1 sin I equal to mu2 sin R. This is how we will write. Okay? Chalo. So this law is universal. This will be true for refraction at any surface. Surface का nature कैसा भी. Now apparent depth. ये इसका क्या मतलब है? जैसे आप लोगों ने देखा होगा, suppose कर लो there is a beaker and what is this is two cases of beaker I'm taking. In first case, there is no water in the beaker and there is a coin, and suppose there is a person here. There is a person here. My drawing is too weak actually, so पता नहीं मैंने क्या बनाया. This is I. So there is a person here, and if he or she looks at the coin, he will find that coin is at what depth? At the depth of beaker. Let it say this depth is D. So for this observer, when the beaker is empty, what will be the depth of this coin or this object? That will be D. Then, so this person will find that the coin is at a depth D. Now fill the same beaker with water and keep the coin there itself, here itself. Now again same person is looking at the coin. Now what he will see? He or she will see? Now he finds that this coin is not at this depth. It will feel like somewhere here, somewhere here. So its position has shifted because we have poured water in it, whose refractive index is different from the refractive index of media in which I is present. I is present in air, okay? I is present in air, and in the case one, this coin was also present in air, so their media was not changing, their media was same, and that is why the actual depth he was able to see. Done. But in this case, what is happening? I is in media air, coin is in media water, media is changing, and that is why this person is not able to find the coin at its real depth. He is finding coin at certain another depth, and that we will call as apparent depth. Okay? So there will be relation between apparent depth and real depth, and how we will write that. देखो यहाँ पे भी derivation is not important, how we are going to write that is important, and also one more thing is important, that is how we write the ray diagram and why it is getting lifted up. ठीक है, तो चलो मैं रे डायग्राम तुम लोगों को पहले बता देती हूँ. सो हियर व्हाट वाज द केस. First thing you need to understand is, if you are looking at somebody, it means what? If you are looking at somebody, it means light is getting reflected by that person and it is falling into your eye. Jaise I am able to see at the board, it means what? Light getting reflected from the board is able to reach my eye. Then first thing you need to understand. So यहाँ पे क्या है? यहाँ पे जो coin है, this person is able to see the coin in first case. It means light getting reflected or light coming from coin is able to reach the eye. ठीक है, so जो observer है, whoever is observing, light will reach to that person. ठीक है, so here सबसे पहले what you have to do, you have to identify what is the object and what is the observer, or who is the object, who is the observer. That's the thing. So here this is object and this is what? Observer. Light will always travel from object to observer for this purpose. If this observer is looking at the object, for this purpose, light is traveling from object to observer. First thing. अब देखो, if light is traveling from this person to this person, what will happen? Light is coming here. Suppose कर लो, light is coming here like this in vertically upward direction. What is going to happen? At this point, light will find another media. So it is traveling from mu to air. So from denser to rarer, it will go away from the normal, right? So light will not go on like this. It will get refracted. And that refraction will be like this. Okay? Similarly, but this was normal now. So इस case में तो नहीं होगा. Sorry. In this case, we took light falling at an angle 0 degree to the normal ना. यहाँ पे मैंने क्या लिया? यहाँ पे देखो, at this point first light that I have taken is falling at an angle 0 degree to the normal, so no refraction. Sorry. Now suppose I'm taking another light which is falling at certain angle to the normal, and if it is falling at certain angle to the normal, what will happen? It will suffer refraction like this. ठीक है, so I को और बड़ा बना लो ऐसे. So ये दोनों, चलो मैं इधर बनाती हूँ. एक काम करो, यहाँ से तुम्हें ऑब्जेक्ट है ये, एन ऑब्जर्वर इज इन एयर समवेयर जस्ट अबव द बीकर सपोज. सो व्हाट विल हैपन? आई एम टेकिंग टू रेज. फर्स्ट रे, ये बाउंड्री बना लो. फर्स्ट रे इज फॉलिंग अलोंग द नॉर्मल, सो नो रिफ्रैक्शन, इट विल गो ऑन लाइक दिस. एंड सेकेंड रे आई हैव टेकन like this and it is making some angle with the normal, so it will suffer refraction and it will go on like this. Suppose कर लो मेरा eye ऐसा. So these two rays are entering my eyes. Now what will happen? I will see the image because of these two rays coming to my eye. I will be able to see the object, but where? Again, image formation will happen. And these two rays of light, refracted rays of light, doesn't seem to meet anywhere actually. They are not, they won't meet anywhere actually. है ना? So what we can do, we can extend them behind. So if I'm going to extend it behind, it is meeting here. So this I will see the object here, lifted up. So from the ray diagram, I can prove that this object won't appear here to this eye. Okay, done. Now how we will find the relationship between apparent depth and real depth? तो लिखने का तरीका देखो ये होता है. First you write real depth, then you divide it with apparent depth. ठीक है, सबसे पहले ये लिख लेना. Done है. Real depth by apparent depth. Always write like this. Equal to करो. Now you have to write it equal to ratio of two refractive indices, whatever you say. So if its refractive index is suppose mu1 and refractive index of air is mu2. So will it be mu1 by mu2 or mu2 by mu1? We often gets confused with this thing. So how to just deny this confusion? Simple thing है, तुम्हें ये देखना है कि light will is traveling from which media to which media. So light will travel from object to observer. Done. So you have to write here refractive index of object divided by refractive index of observer. ठीक है, यानी कि if light is traveling from mu1 to mu2, so here I will write mu1 by mu2. So real depth by apparent depth is equal to ratio of refractive indices, and that is equal to how much? Mu1 by mu2 here. Why? Because light is traveling from mu1 to mu2. So you have to see कि light is traveling from which media to which media. Simple. And that is how you will write the formula. Again, here if you have to calculate if real velocity of, suppose this object is moving upward. So you will be asked what will be the apparent velocity. So simple thing what you need to do here is you need to simply differentiate this position relation. ठीक है, तो यहाँ पे आप क्या करोगे, रियल को सपोज कर लो, मैं एच आर लिखती हूँ, तो एच आर इज इक्वल टू एच एपरेंट म्यू वन बाई म्यू टू. So you will differentiate this with time, this with time, this is constant, so it will remain outside. So velocity, real velocity will be equal to apparent velocity into mu1 by mu here for this case only, right? Because here light is traveling from mu1 to mu2. So this is how we deal with things. Now we will solve question. Okay. Anyone having any doubt in previous topic in this thing? So if you have understood this now, you have covered refraction through plane surface. Now all question in refraction through plane surface will revolve around this concept. Nothing else you need to understand in concept term. But yes, from question solving, you will learn a lot of different other things. Okay, so let's do that now. Okay, let me know. This is purely based on real depth by apparent depth. So I hope you all will solve it. Let me give you 2 minutes. Take 2 minutes and solve it. If you get a doubt in understanding the question, let Chain B, Y chart. Yes, very good. That's like a smart person, you know. And that's like a person who really listen in the class. Always it's not about being intelligent while you win, you know. Most of the time it's all about your persistence, your willingness to work, and your dedication. So just add that to your studies. चलो सारे लोग बताओ क्या क्या आंसर आ रहा है. Some people or some JNV joining off and on, like you people are not continuous, not consistent. How this is going to help you, yeah? From today onwards, also you should decide you have to be consistent. And you need to be actually. Otherwise, you're not going to gain anything. Let me tell you very frankly. I don't want to fool you. I just want to tell you the truth so that you can work over that. Others, please. If you've really focused on things that I have taught, you will be able to answer. They're on YouTube also. Let me know the answer that you're getting. That one person who is there watching on YouTube. Okay. चलो ठीक है. So what the question was? Question ये है कि यहाँ पे ग्लास स्लैब है, ठीक है, an air bubble in glass slab of refractive index, its refractive index is 1.5, and there is an air bubble which is 5 centimeter deep when viewed from one surface. So it has two surfaces, 1 and 2. So in first case, observer is here. He is watching this what air bubble from this side, and also the same person is watching the air bubble again from this side. So observer is once it is here, another time it is here, and when it is here, he finds that this air bubble is at what centimeter depth? 5 centimeters. So he finds that air bubble is at a depth of 5 centimeter, and he finds that air bubble is at a depth of how much? 3 centimeter. And it doesn't mean कि depth of the slab is 8 centimeter. No, because these are apparent depth. जैसे क्वेश्चन में क्या कहा गया है, when viewed from one side it is 5 centimeter deep. It means this is apparent depth, right? And when viewed from another side it is 3 centimeter. Done. So chalo, first I will deal with from the one side. So suppose कर लो, initial original position of bubble is here at some depth d. Original position of bubble is at some depth d, and original height of this slab is h. Okay, so original position is this. Observer is here, and he is looking at this bubble, and he finds that it is not at a depth d, it is at a depth 5 centimeter. So real depth, that is d, divided by apparent depth, that is 5, will be equal to, we will see ray of light is traveling from where to where. So from object to observer, it will travel from here to. So this is 1.5 by 1. So d is equal to how much? It will travel from here to here, right? So this is equal to how much? 7.5, right? Now you just see here. For another case, if you find real depth will be how much? H minus d. And apparent depth is how much? 3 centimeters. So real depth by apparent depth, you do the same thing again. So it will be how much? Real depth, that is h minus t, by apparent depth, that is your 3 centimeter, and that will be equal to, again light will travel from object to observer. So this is 1.5. This is this. So h minus d equal to how much? 4.5. And here d is how much? 7.5. So h will be equal to 7.5 plus 4.5. So this is equal to 12. What we were asked, the thickness of the slab. So thickness of slab is h, and h we are getting as 12 cm. So correct answer will be what? 12 cm. Okay. So correct answer will be C. I hope you got it. Now there is a thing called optical length. देखो one by one I'm covering small topics. ठीक है? So what is optical length? जैसे in vacuum, then where refractive index is what? 1. Or in air, we generally assume in air refractive index is what? 1. Suppose light is traveling from here to here, from point A to point B. So what is the geometrical length of this light beam? Geometrical length of this light ray, better we should call it ray. Okay. So geometrical length of this light ray is how much? चलो मैं यहाँ लिखती हूँ. So geometrical length is how much? LAB. ठीक है? Length of AB. That is its geometrical length. But there is a term called optical length. So optically, how much this light has traveled? Geometrically, this light has traveled AB length. Optically, how much it travels? So optical length is nothing but the refractive index of media into geometrical length. That is LA. So this is your optical length. You should keep this in mind because when we will read wave optics, there also this optical length will come into account. It will come into questions or consideration everywhere we will get. Okay? So chalo, isko yaad rakho. From this, we have got a question here also. So this came in 2019 G-Mains. So let's do it. And I will give you 1.5 minutes. Question is very easy. Do it. Just geometry and the concept of optical length, nothing else. Do solve it and let me know the answer. So I'm expecting more answers this time. From A to B, you have to tell the length of optical length of the line. Okay. Geometrical length you can calculate from the geometry. जैसे यहाँ से you can calculate OA, and from this triangle you can calculate OB. Once you have calculated OA, its geometrical length is OA. Optical length will be how much? Mu times geometrical length, है ना? So you have got no. This won't be the answer. How are you getting this? Geometry you have not solved in a right way. Look at it more carefully. You need to calculate OA, right? And vacuum का refractive index क्या होता है? 1. Glass का refractive index, if it is not given in the question, you will take it as what? 1.5. ठीक है? Then for glass it is 1.5 always, if nothing is given. Yeah, from this triangle calculate OA. This angle is 60, this will be 30 degree. So A, this height by hypotenuse. Height value is how much? A. Hypotenuse is what? OA. Height by hypotenuse is what? Sine. So sine 30. That is 1 by 2. Okay. So OA is equal to what? 2A. This is the geometrical length. And what will be its optical length? Same, because refractive index is 1. So this is optical length also. Now let's solve same thing for OB. If you go for OB, what will be the thing? Let's come in this triangle. This is given as B. And this is hypotenuse OB we need to calculate. So base by hypotenuse is what? Cos. So this is B by OB. Cos 30. Cos 30 is how much? Root 3 by 2. OB is equal to how much? 2B by root 3. Okay? This is your 2B by root 3. And here refractive index should be what? It should be actually here in the question. Okay, nothing is given regarding mu of glass, but if I take it as 1.5, answer should be what? This is the geometrical length, right? Optical length should be what? I feel in the answer they have neglected mu, but it should be given. Anyway, I will recheck with the answer. Okay. So 1.5 into ideally it should be this. 1.5 means 3 by 2. So if you're going to solve it, this is 3 by 2 and 3 से root 3 cancel होगा, यहाँ root 3 होगा. This 2 will get cancelled, so it will become root 3b. Done. So optical length will be equal to how much? It will be equal to 2a plus root 3b. But in answer, it's given like this, but it should not come. This is the geometrical length. Optical length should be different. Okay, I will recheck with this. No problem. Anyone can suggest anything for this question? If you can see, if you are able to see, क्योंकि मुझे दिख नहीं रहा. Okay, so if one thing I can see here, if refractive index is not given, we can apply Snell's law and calculate refractive index. ठीक है? So before assuming कि refractive index क्या है, if we have option to calculate it, we can do that. Let's see now. क्या पता वो भी mu2 भी 1 आ जाए. So apply Snell's law at O. So mu1 sine 30, sorry 60 will be equal to mu2 sine 30. है ना? And this is your what? Mu1 is 1, sine 60 means root 3 by 2. And mu2 is how much? Mu2 is your mu2. Sine 30 is how much? 1 by 2. So mu2 is equal to root 3 actually. So mu2 we are getting here as root 3. Okay, okay, okay. C will be the correct answer. Thank you so much. Okay, you should have suggested me, right? I forgot. 2b by root 3 into क्या करोगे? Root 3. So correct answer should be what? Its optical length will be 2b. Its optical length is 2a. So a correct answer should be C, not D. Okay, thank you. Now intensity of light in terms of electric field and magnetic field. That we will cover also in electromagnetic wave that I have escaped for now. That we will discuss in the last. Okay. So here if you see, suppose कर लो light. Don't get confused with the topic. I will explain it. जैसे light को क्या कहते हो तुम लोग? Electromagnetic wave. You say it like this, right? It means light has both electric field and magnetic field. Done. And light will have certain intensity. Intensity is what? Amount of light falling per unit area, per unit, sorry, amount of energy. Intensity को क्या कहते हैं? Amount of energy falling per unit time, per unit area. यानी कि power per unit area is your intensity because energy by time is power. So this is intensity. If we have to write intensity in terms of what? In terms of magnetic field or electric field, how we will write that? How epsilon naught E का square C. अब इसका क्या मतलब है वो मैं एक्सप्लेन करती हूँ. So if light is falling in vacuum, suppose light is falling in vacuum and there is an area upon which light is falling. Media is what? Vacuum. Light is traveling in vacuum. So this is this. And this light will have electric field. So if it has electric field, its electric field equation will look like, sorry, graph will look like this. Similarly, magnetic field graph will also look like this. So this electric field line will have some amplitude. And this E is nothing but the amplitude of electric field. Okay? And this C is what? Velocity of light. Since light here is traveling in vacuum, I have taken speed as C, 3 into 10 to the power 7 meter. That is 8 now. 3 into 10 to the power 8 meter per second. This is epsilon naught. This is permittivity in vacuum. But if light is not supposed traveling in vacuum, it is traveling in some media. So in that case, if it is a media other than vacuum, in that case, we will write intensity as what? Half epsilon E square V. इसका क्या मतलब है? V is the speed of light in that media. Epsilon is permittivity of that media. Now, how to further simplify? तो इसके लिए ना तुम्हें कुछ कुछ चीजें याद रखनी होगी. और वो क्या कुछ चीजें हैं? Velocity of light we write as what? Velocity in any media is written as what? तुम लोग पढ़े होगे पहले भी refractive index कैसे define करते हैं. So how we define refractive index? Mu is defined as velocity of light in vacuum divided by velocity of light in that media. So for any media, if you're going to calculate a refractive index, that will be written as velocity of light in vacuum by velocity of light in that. Done. So V you can replace as what? V you can replace as C by mu. ठीक है. First thing. And second thing is what? Epsilon के साथ क्या करना है? So you already know epsilon is equal to epsilon not epsilon r. That I have explained in electrostat also. So this is this. और एक चीज और है जो तुम लोगों को याद रखनी है, स्पीड ऑफ लाइट को एप्सिलन और म्यू के टर्म में लिख सकते हैं हम लोग, एंड दैट इज रिटेन एज व्हाट, that is written as speed of light in any media is written as root under epsilon r v1. ठीक है, these are the things you need to remember to solve questions related to intensity of light in terms of electric field and magnetic field. तुम लोग सोच रहे हो कि मैग्नेटिक फील्ड के टर्म में इस इंटेंसिटी को कैसे लिखा जाए, सो दैट वी कैन राइट हाफ एप्सिलन को किस में कन्वर्ट कर देंगे, 1/म्यू में, ई स्क्वायर की जगह क्या लिखोगे, बी स्क्वायर, एंड वेलोसिटी की जगह वेलोसिटी, लाइक दिस. ठीक है, सो एप्सिलन को एप्सिलन नॉट एप्सिलन आर कर सकते हो. सिमिलरली म्यू को क्या कर सकते हो, म्यू नॉट म्यू आर कर सकते हो. ठीक है, एंड वेलोसिटी ऑफ लाइट इज इक्वल टू हाउ मच, दैट इज इक्वल टू, आई गेस हियर आई हैव रिटन इट रॉन्ग, मेरी मेमोरी थोड़ी खराब हो गई है, क्योंकि आई हैव सीन इट इन द मॉर्निंग आल्सो. It is, I guess, epsilon mu. Sorry, I got disconnected. Uh, Let me reshare. ठीक है, I needed to check the velocity of light formula in terms of this, right? So, can anyone suggest if this is right or okay? That sounds like correct actually. Anyway, I will look at it, but for now, take it like this. अब देखो, you can change everything. एप्सिलन की जगह आप क्या लिख सकते हो, हाफ एप्सिलन नॉट एप्सिलन आर ई स्क्वायर. v की जगह आप क्या लिख सकते हो, c बाई म्यू लिख सकते हो. म्यू की म्यू जो तुम्हारा है, इफ दैट इज गिवन इन द क्वेश्चन, मींस व्हाट एवर इज गिवन इन द क्वेश्चन, अकॉर्डिंग टू दैट यू कैन रीअरेंज दिस इक्वेशन. ठीक है, डन. सो लेट्स डू वन क्वेश्चन दैट केम एक्चुअली इन 2019. so again I'm giving you 1.5 minutes, do this question and let me know the answer. ठीक है, क्वेश्चन को ध्यान से पढ़ो एंड लेट मी नो. I will check with the velocity. Okay? But that's correct. It sounds like. Anyway, do this question. Let me know. Yeah, that's correct actually. क्वेश्चन क्या है, क्वेश्चन समझ रहे हो ना. लाइट वेव इज इंसिडेंट नॉर्मली ऑन ए ग्लास स्लैब. मैं थोड़ा असिस्ट करती हूँ. नॉर्मली ऑन ए ग्लास स्लैब इट इज फॉलिंग, राइट, and the refractive index of the media is how much, 1.5 it is given. 4% of light gets reflected, so 4% of light is getting reflected and raised, and the amplitude of electric field of incident light is 30 वोल्ट पर मीटर, इंसिडेंट लाइट का क्या था 30 वोल्ट पर मीटर है. Then the amplitude of electric field will for the wave propagating in the glass medium. So 4% is getting reflected, rest will go in the glass media. ठीक है, it will get transported to glass media. So 4% is going reflected. How much percentage of light is coming to the glass media? 96%. So if incident light's intensity is I, then 0.04 I is getting reflected back to the same media, and 0.96 I is getting transported to the glass media. So intensity of light in the glass media is how much? 0.96 I, where I and 0.04 I is getting reflected. Okay. Then where I is what? Intensity of light in this media. Done. In I is what? Initial intensity of light. So I को तुम कैसे लिख सकते हो? जैसे देखो यहाँ पे ग्लास स्लैब पे लाइट फॉल किया है, ठीक है, तो डेफिनेटली कमिंग फ्रॉम एयर, राइट? सो वी कैन अज्यूम दैट इट्स कमिंग फ्रॉम वैक्यूम, राइट? ओके, चेन बी वाइजर, इट्स करेक्ट, वेरी गुड. चलो, one answer I have got, and also we are running out of time. So in the next class or in next discussion, I will discuss more questions. We will discuss from refraction through plane surface. We need to actually, and after that I will discuss. So next weekend on Saturday we will devote all time to refraction through plane surface itself, and on Sunday we will cover questions from refraction through curved surface, right? So in these 7 days in between, that lies in between, keep reading and keep focusing on yourself. Do work, don't take tension, and focus more on studies. Okay. Chalo, bye bye, take care. And any help if you want out of me, let me know. Anyone has anything to say, or any help, or any request, or any complaint, anything, if you have. नहीं है, चलो ठीक है, bye bye, take care.